Today we'll be talking about the physiology of depression and novel research avenues which are contributing to our understanding of the disease and new treatment options. But first, let's start with some facts about depression. It is the most common, costly, and important disability worldwide. 264 million is the number of people of all ages suffering globally. 2.74 million is the number of annual deaths globally from depression. And 1.86 is the relative risk of mortality for depressed people of all causes compared to non-depressed people. So what do we know about depression and its physiology? And what important factors do we not know yet? Well, what we know is that it is primarily a disease of the brain. However, it is often reduced to a simple chemical imbalance when it is actually much more complex than this. This is because the brain does not exist in isolation, but is embedded in the overall physiology of the individual. This means there are many possible causes of depression, such as nerve and hippocampus functioning, genetic vulnerability, stressful life events, medications, or medical problems such as thyroid hormone imbalances. It is often a combination of these factors which interact and bring on depression. To make things more complicated, depressive pathophysiology can vary over the course of the illness. So what are the current treatments for depression and how effective are they? Current psychological treatments for depression include cognitive behavior therapy, which is proven to be one of the most effective, and mindfulness-based cognitive therapy, which is often used in combination. Pharmacological treatments for depression include antidepressant medication, which is proven useful for treatment in moderate to severe cases. However, even when psychological and pharmacological treatments are combined, they are effective in only about 74% of cases. Therefore, investigation into more physiological factors and pathways that might contribute to the state of the brain during depression is needed. So let's switch gears now and chat about recent research into the link between depression and the gut. This valuable pathway has been receiving a lot of attention recently, as a significant amount of data has established that depression is associated with altered gut microbiota composition, generally in the form of reduced richness and diversity. A comparison of gut microbiota of patients with depression and healthy individuals revealed significant alterations in the abundance of the two dominant families, Bacteroidetes and Firmicutes phyla. These changes are relevant to mood state because gut microbiota interact with the brain by neuroimmune, neuroendocrine, and neural pathways. So now let's look at the evidence. The first piece of evidence, and potentially the most conclusive, is shown through gut microbial transplantations. This finding was reported by Zhang and Kelly, who performed FMT from depressed patients into microbiota-depleted rat models. Both showed behavioral changes that correlated with human depression and anxiety, and characteristic physiological features following the procedure. It is hypothesized that this occurs via activation of vagal afferent fibers, or by production of humoral chemicals that ultimately enter the brain, thus affecting mental health. The next piece of evidence was discovered through a groundbreaking functional MRI brain scan study by Tillich in 2013, which showed that ingestion of a probiotic cocktail altered information processing of emotional material. And in another human intervention study, healthy volunteers were given lactobacillus and bifidobacterium in combination or placebo for 30 days. The findings showed 24-hour urinary-free cortisol output was reduced with probiotic treatment. This effect is most likely dependent on alterations of the HPA axis, which these studies have shown can be positively influenced by certain probiotic bacterial species. The last piece of evidence is studies of bacterial counts by Ozawa in 2016, which show reduced counts of pre- and probiotics in the gut are more common in patients suffering depression compared to healthy control. Patients had significantly lower levels of bifidobacterium and tended to have lower lactobacillus counts. These findings provide evidence to the use of pre- and probiotic supplements in the treatment of depression. So what does this all mean? Well, this understanding leads us to some promising and quite simple treatment avenues. The first being diet. This involves introducing a huge variety into your diet, with particular emphasis on fruits, vegetables, fermented foods, whole grains, protein, omega-3, and zinc. This is essential for a diverse and plentiful gut microbiota. The next is probiotics. For the level and diversity and count you cannot get from your diet, probiotics are used. These also act in a more timely manner than using diet alone. Finally, there is FMT, or fecal microbiota transplantation. This involves the infusion of healthy human donor feces into the bowel of the recipient to repair their microbiome. And so to conclude, increasing the diversity and count of your microbiota can significantly aid in the treatment of depression due to its positive influence on the gut-brain axis. Further research into this relationship will aid in a more defined, targeted, and effective treatment option for those suffering depression.